And we want to welcome this month research ecologist Sean Parks coming to us from Missoula, Montana. Education background of UC Davis and the University of Montana, neither of which are Purdue University, who will be playing in the Final Four this weekend. Boiler up. Okay, with that, Sean's going to talk to us about fire, and I think this is the first NECI webinar that we've really had talking about wildfire. So great to hear from you, Sean. Take it away.
All right. Thanks for having me. And I'm just going to ask you to confirm that you see my screen, Hans, and that it's not the presenter mode.
Yes, we see your screen, and I want to mention, if you wouldn't mind, please place the location that you're reporting in from in the chat for Sean. He'd like to know exactly who he's talking to and where they're from.
Yeah, hi everybody. I hope your day is swell. Um, I am, as Hans mentioned, in Missoula, Montana. I work for the Forest Service and specifically for the research and development branch of the Forest Service for an entity called the Rocky Mountain Research Station, and within the Rocky Mountain Research Station, a program called the Aldo Leopold Wilderness Research Institute. And so, yeah, I'm excited to talk to you today about fire regimes and fires of the Anthropocene. And I also want to mention, I know folks listening are from all over the country. I'll say this is a very Western US based talk, and I apologize for that, but I do focus on fires in the Western US and also focus more specifically on forest fires, not necessarily grass fires or shrub fires, um, or or fires that um, directly impact communities. But with that, I will get going here. So it's probably no surprise to anyone listening that there's been a fairly large increase in area burned since basically the last 40 to 50 years. And, what's somewhat concerning is that these increases appear to be non-linear, as shown down at the bottom left. It's the increase in fires is continually increasing through time, I guess. So this non-linear increase. Uh, you know, and I'd be surprised, or I'm guessing that most of you were actually impacted by smoke at some point over the last few years. I know smoke hammered the West Coast in 2020 and maybe 2021, and then on the East Coast in 2023 from the Canadian fires. So, and we get a lot of smoke here in Montana almost every year. So, uh, fires, uh, a big deal. And so fires increasing, and this is attributed to climate change. Here's a plot showing, or a couple plots showing area burned as a function of a couple climate variables. The left one is vapor pressure deficit, which is a metric of atmospheric dryness. So the higher the VPD, the more dry the atmosphere is. And then the right plot there is Tmax, or the temperature of basically mean summertime temperature, or mean summertime temperature, the high, whatever. Summertime temperature is the way you can think about it. And so what you see is, of course, that warmer and drier fire seasons are associated with increases in area burned. And again, I have 2020 and 2021 highlighted here because these are, what might be considered outliers in these relationships, or maybe not outliers, but they were, some of the most extreme climate we've seen, and definitely the most extreme fire we've seen in terms of area burned. Getting back to how it's affecting, even though these fires are occurring in forests, it's affecting major population centers across the country. Here's a couple of photos from 2020 in Portland and San Francisco, and the smoke was pretty bad. And I, not to be an alarmist, but this is alarming. Mainly this non-linear increase in area burns as a function of these these climate variables. Um, so basically a little bit increase in vapor pressure deficit or a little bit increase in summertime temperature, we're seeing, um, you know, just more and more area burned, right? And then when we put that in the context of climate change, it's even more alarming. So as an example, I'm plotting those two variables, again, temperature and vapor pressure deficit along each other. Each black dot represents 1 year from 1986 to 2015. And these climate variables are scaled so that 0 is the mean. So values above 0 are warmer and drier than average, and values below 0 are cooler and wetter than average. And again, each dot is representing 1 year from 1986 to 2015. And I also plotted 2020 there. So again, showing how 2020 was an extreme year in terms of climate. And I previously showed how it was an extreme year in terms of fire. But when we look at climate change, this is where things get, kind of concerning, is that each black dot on the right is basically a hypothetical year in mid-century to show the variability in climate that we might see around mid-century. Again, there's temperature and vapor pressure deficit. And if you plot 2020 for this mid-century climate, 2020 is more or less kind of like an average year under mid-century climate. So 2020 could be considered the new normal. Not everyone likes that term, but I'm using it here. And so if 2020 is the new normal in terms of climate or of the emerging climate, and the 2020 fire season is the new normal of our mid-century climate, then we're in for a lot of smoke, right? And a lot of fire. So I do want to take a step back and look at basically a longer term perspective of fire, look farther back in time than the last 40 to 50 years. So this is a complicated figure, and I'll walk you through it. It's just that if you're looking at the plot on the right, the red line is a metric of fire, and this is basically figured out through charcoal in lake sediment. And the black dotted line behind it is a metric of climate. And so what you see is for the last 1400 years, this goes back quite a bit, the last 1400 years, fire and climate were more or less coupled. As you can see, the black line, the black dotted line, and the red bold line are following each other, right? You even see some major climate anomalies show up in this pattern. You can see the medieval warming period between 800 and 1,000 years ago, and we also see the little ice age, around 350 years ago. So, with these climate anomalies show different, the fire is reacting. We've got more fire in the medieval warming period and less fire in the middle ice age. But you can see about 110 or 100 years ago or so, these lines split. The climate is shooting up to the right, which means it's getting warm, and the fire is diving, which means there's a lot less fire than we might expect. And so this has been coined the fire deficit, or a fire deficit, because the fire is no longer tracking climate as it did for the previous 1,000 years before about the late 1800s. Another way to look at this fire deficit is to look at these fire scar data across the country or across the continent even. This guy on the left, this photo on the left, shows a cross section of a tree. And historically, fires burned and they would damage a tree, and the tree would continue to grow, but the fire wouldn't necessarily kill the tree. And it left what are called fire scars. And you can see these tick marks in the wood here. And these tick marks can be attributed to individual years, and that's shown as well, right? And then again, right around 1880, fire gets turned off, and again, it's the fire deficit, right? So fire's burned, every 10 to 20 years for this particular tree. If we look at all the fire scar records across the continent, there's over 1,800 of them. We can start to get a picture of how widespread fire was historically. And so we've done that. This is a very current project for my team and I. And this is how we're summarizing. So this is historical fires from 1600 to 1880. And in 1728, 29% of the sites burned. And I hope you can see my cursor, by the way, because I'm kind of using it. So that's a lot of fire, right? 29% of the sites burned across the continent in 1748. In 1729, 21% of the sites burned. In 1685, 19% of the sites burned. So we could take these 1,850 sites and overlay it with maps of contemporary fire, which we've done, and make a comparison. And this is what it looks like in the orange, right? So that's fires from 1984 to 2022. And in 2020, 6% of the sites burned. And so, as we go through our life and our days, during these fire seasons, the media and others use terms like unprecedented, like 2020 was an unprecedented fire year. And sure, maybe it's unprecedented, since, in the last 50 to 100 years. But when you take this longer term perspective, this multi-century perspective back to 1600, the year 2020 was not unprecedented at all. There were many, many years in which there was more fire across the continent. And so why is this? Why do we have this fire deficit? So again, this just kind of reinforces this idea of a fire deficit. So why is it? Well, we as society basically put out most fires. And in addition to that, we're not doing very much intentional burning. So, this Crystal Colden here argues, and I would agree, that we are not doing enough prescribed fire in the Western US to mitigate fire risk. And then also historically, prior to, Euro-American settlement of the continent, there was a lot of fire started by indigenous peoples or Native Americans, right? So, and there was a lot. Like, part of my job is, I learn, I like learn stuff almost every day. I feel like I'm a student, even though I've, have a PhD. I'm continually a student, and I'm learning more and more about fire all the time. And I'm learning how much fire indigenous peoples used across the continent historically. It's getting to be a very large area of research. There's a lot of really cool papers coming out about the historical role of human ignited fires. And really what they've concluded, all these papers conclude, is that there's no way that lightning ignitions alone can explain the amount of fire that historically occurred. That people were definitely playing a role in lighting these fires. So I'm here on the one hand telling y'all that there's a fire deficit. And on the other hand, I'm saying, hey, fire is increasing through time and it's attributed to climate change. So what gives, right? How do we reconcile or explain this? I'll just kind of try to explain it again with another plot here. Again, the top plot is showing some metric of fire using tree ring fire scars. Again, there's a picture of it at the bottom left, through time. And then right at about late 1800s, fire just tanks, right? But then it picks back up again, right, in about the mid 80s. And that's what we're seeing in the bottom right plot, right? So we are seeing increases in fire. It is due to climate and climate change, but it's still less than we as a continent experienced historically. And what I think is going on is just that it's because of warming and drying climate, is becoming harder and harder for us as a society to continually put out these fires, even though we try very hard to. So I know what you're thinking. You're thinking, you know what? So what if we're putting out the fires because fires are bad? They're smoking out the cities. They are having some severe negative impacts on our communities, which is very unfortunate. But there's some other stuff going on when we perpetually or try to perpetually remove fire. We get basically a lot of changes to our forests. So the right top photo shows, a forest from the late 1800s, larger trees, very open. And then 1880 hits, the fire gets turned off. And what happens is we just get a lot of growth of trees, of these small diameter trees. These are thin barked trees that are not resistant to fire. We also, we also get more accumulation of dead fuels on the ground. So the way I like try to think of this is that historically in some of these forests, fire was like basically a forest lawnmower, I guess. They burned every 5 to 10 to 20 years and killed the small trees, consumed the small trees, consumed the dead biomass on the ground, sticks and logs and what have you, and, and needles that fell off the trees. And so this lawnmower basically kept the forest in a certain condition, as is shown up there in the top right photo. And then once we turned off the fire lawnmower, the forest tends to get overgrown, right? As you can see at the bottom right. And when it's all said and done, this impact is basically ubiquitous across a lot of forests in Western North America, as described by this paper here shown on the left. And again, I could see how people might say, well, you know what? So what if the forests are getting thick? That's no biggie. Who cares, right? But the problem is that once the forests get these thick, um, they're going to burn at some point in time. And that's something that me and other fire scientists out there try to continually, remind people that fire is inevitable. We cannot remove fire in perpetuity because we've been trying to do that, right? And we were successful for a very long time, but we're no longer that successful at it as, as witnessed by the last few fire seasons or even the fire seasons over the last couple decades. So when that inevitable fire occurs, though, we tend to have these effects of the fire or what we call the severity of the fire that tend to be very uncharacteristic of that forest type. Or these fires are much more severe than they were historically in these same sites. So this photo is in the exact same spot. And you can see at the top left, imagine a fire going through there. It would probably, kill those smaller trees, but leave those larger trees there. If we're lucky, it would record a fire with a fire scar. But then when you remove the fire, you just get all this ingrowth. And then we have this inevitable fire that occurred in 2012. And here's a photo of the aftermath of that. And we're seeing this more and more. And so what's happening is these forests historically had had fairly high fire frequency, but burned at low severity. But due to ongoing fire suppression and fire exclusion and the accumulation of fuels, which when I say fuels, I mean live and dead trees, these dry forests have moved from this high frequency, lower severity quadrat to a high severity but low fire frequency area of, of space, I guess, of data space. And again, here's another example of the inevitable fire. This is in Colorado. You can see the top photo is from, the late 1800s, fairly open forest. Over 100 years of fire exclusion, the forest got very thick. The inevitable fire occurred in 2002. This is the Hayman fire in Colorado. And this is what it looks like in 2020. So I want to talk more about fire severity because when we read, news on the internet or the newspapers or whatever, it's often talked about how much area burned or how big a fire got. You may have heard the term mega fire, right? But I'm going to argue that this idea of area burned is not as important as thinking about how the fire burns. And when I say how the fire burns, I'm talking about, again, the severity of the fire. So here's a schematic of what I'm talking about. When I talk about high severity fire or stand replacing fire, it's a fire that kills all or most of the trees. So fire not all fire is bad, I guess is kind of what I'm trying to say. So when we use stats like fire size or area burned, it could actually be a decent fire that's actually acting as the appropriate, kind of forest lawnmower that I was talking about earlier, or it could be help consuming the fuels and making the forest more resilient to that next inevitable fire. Um, so not all fire is bad, right? So I focus a lot of my research on looking at high severity fire or stand replacing fire. So if we go back to this plot again, where I showed earlier that showed a tenfold increase in area burned since 1985, if we look at annual area burned at high severity, we see a similar trend. We see a 16-fold increase in area burned since 1985. And so, um, again, this is why, well, I'll stop there. So this is a trend through time. There's some other research out there that shows um, how fire has changed as a proportion of area burned. So this study that I was involved with showed that for dry conifer forests in the Western US, we are seeing 3 to 14 times more stand replacing fire as a proportion of area burned compared to the historical fire regime. So fires are burning in a manner that's not good for our forests, right? And I'll explain why coming up right here. Basically, these stand replacing fires or high severity fires can catalyze shifts from forest to non-forest, and especially the lower elevation, drier forest types. All these photos are from forests that historically experienced frequent and low severity fire. And the fires that have gone through over the last couple of decades have killed, have killed most of the trees in these photos. The center photo in particular is fairly shocking to me because this is an area that has a lot of giant sequoia in California, and giant sequoias are some of the most fire resistant trees out there, meaning they've got very thick bark and they historically survived, almost countless fires. And now the contemporary fires that we're seeing recently are killing these very fire resilient trees. So I want to touch a little bit on this kind of what I call a pseudo debate between fuel versus climate, and I'll explain what I mean here. But like, um, there are what I'll call special interest groups, I guess, from basically opposing political ideologies, maybe, that like to lay blame about why we're seeing so much fire. And some groups say, oh, it's a fuel problem, meaning there's too many trees on the landscape. And other people say, or other groups might say, oh, it's a climate problem. And where this stems from is that there are groups that are like say pro logging or something like that, and they want to say, okay, fuels are the problem. We can solve the fire problem by removing trees from the landscape. And then there's other special interest groups that say, you know what, we don't like forest management at all. It's all climate. No matter what we do, the climate is changing, and we're going to continually have fire. And so, both of these kind of opposing views in my mind are, well, there's a nuanced story here that I'm going to tell you, but they're both, I don't know, both trying to trick us, I think. So when we're thinking about fire regimes, the most important fire regime components are fire frequency or annual area burned and fire severity. There's other fire regime components down here, intensity, seasonality, but I'm going to talk about annual area burned and fire severity. These are like by far the most important fire regime components. So if we look at area burned through time, here's another plot that shows how there's been a 6-fold increase in area burned from 1985 to 2017. And in 2010, 710 square kilometers burned. And in 2012, 8,800 kilometers burned. Here's another set of maps, or a set of maps from the Selway Bitterroot Wilderness, which is central Idaho and western Montana. In 2004, 1,800 acres burned. And in 2007, 92,000 acres burned. These changes in area burned are not due to fuel accumulation or changes in fuels at all, right? This is entirely due to the climate of the fire season climate. 2010 and 2004 in these areas tends to be cooler and wetter fire seasons, so we didn't have much fire. And in 2012, um, and in 2007 in the Selway Bitter Wilderness, there was warmer and drier fire seasons than average. And so we have extremely elevated area burned. So really, no matter how much forest management or fuels management we do, we're still going to see a lot of fire during these warm and dry fire seasons. On the other hand, when we're thinking about fire severity, it's a fuels thing for sure. Um, there's research out there that shows that fuels are what's controlling fire severity. Um, in a study that I was participated in, we found that fuels were about 2.5 times more important than weather and fire season climate in driving fire severity. And common sense also kind of tells us this about what's driving fire severity, right? In the top two photos here from, before the fuel accumulation compared to the bottom two photos, you can imagine if a fire goes through each of these scenarios, just which one is going to experience higher severity fire, right? So really, it's that fuels and climate are driving fire regimes or are responsible for changing fire regimes. And so, annual area burned is primarily driven by fire season climate, but the severity at which those fires burn is primarily driven by fuels. And again, by fuels, I mean the amount of live and dead vegetation out on the landscape or the amount of biomass that's on the landscape. So if fire is inevitable, which it is, and if the severity is so high, what do we do about it? Well, a lot of folks out there, including me, are suggesting that proactive fire management is necessary to reduce fire severity. We can't use proactive fire management to really stop the fires because I mentioned that climate is primarily driving fires, fire size or area burned, but fire severity can be modified. There's this great video put out by Dr. Paul Hesburgh called "The Era of Megafires," and in this video, he's also a scientist with the Forest Service. He asks, how do we want our smoke and how do we want our fire? And if you've got time, I would definitely check that out. But notice I'm calling this proactive fire management. I'm not calling it forest management or anything like that. I'm calling it's fire management because the fire is inevitable. So we can treat the fire or affect the fire before it happens through proactive fire management. I want to briefly touch on lessons learned from the wilderness. Wilderness in the United States is some of the most highly protected land status. There's no mechanized travel and what have you, and there's no logging and forest management. But in some of these really large wilderness areas in the Western U.S., some of them have a decades-long successful policy of allowing lightning ignited fires to burn in the absence of suppression, or I would say with probably maybe minimal fire suppression effects on it. And what we're seeing, this is the Gila Aldo Leopold Wilderness Area. This is in New Mexico, in southwestern New Mexico. And this is probably the gold star of or like an exemplary example of allowing, if we had allowed fires to burn, what our forests look like, basically after repeated fires. And so in the Gila Wilderness, again, decades-long policy of less aggressive suppression. You can see in the bottom left map, there's been a lot of places in the wilderness have burned 4 times or more. And then in 2021, the Johnson Fire burned, and it's shown as by the red polygon here. Hopefully you can see my cursor. So it burned 90,000 acres, not a small fire at all. And I went through with high resolution imagery and looked at before the fire and after the fire to see how severe the fire burned. And basically almost everywhere where there was a live forest before the fire, there was a live forest after the fire. So again, this just, I guess, illustrates, and this is a lot different than the rest of than what we're seeing outside of wilderness or outside of this wilderness, where we're seeing a lot of those high severity fire effects that I mentioned earlier. So just some take-home messages here as I wrap this sucker up is that, 2020 is basically the new normal in terms of climate, according to our mid-century projections. And, if fire follows climate as tracks climate as it's been, if 2020 is our kind of new normal for fire, then we have a lot of fire to deal with. And as a society, we need to try to figure out how to deal with that. Another take-home message is just this idea of the fire deficit and that it's resulted in this excessive fuel buildup. And then also want to, remind everyone that forest fire is inevitable. We try our best to remove fire, but we're still seeing fire in the landscape. And so because of that, I guess I'll jump down to number 6 here. Because fire is inevitable, proactive fire management is a potential solution. And because of this excessive fuel buildup and fires inevitable, the contemporary fires we're seeing are not consistent with the historical time periods in terms of the severity of these fires. Fires are much higher severity than they were historically. I also just want everyone to remember or, think about the historical importance of human ignited fires, because it does provide us some context and relevance in terms of how fires historically burned, how forests were historically shaped, and also gives us some context for maybe how much prescribed fire that we need to put on the landscape to return our forests to a more resilient state. And lastly, just again, this idea of proactive fire management, because fire is inevitable, we can treat the fire before the fire occurs through proactive fire management. So that's all I have for you. Thanks for attending. I'm going to stop my sharing and take any questions.
All right, yeah. So in the chat, we do have one question from David referencing the era of megafires resource that you described. And I can't really state that verbally, so you'll just have to check out the chat and see if that's the correct reference.
Oh, okay. Let me see. Paul Hesburgh, there's a few iterations out there. He's got like a TED Talk that's 5 minutes. He's got this longer, whoa. All right, the one you showed, it looks like it's, oh, that one's only a couple minutes. That's only a 2.5 minutes. So it's not the one, it's not the correct one. But I think if you Google Paul Hesburgh and era of megafires, you can look around, but there's various versions of it, because I call him, when he was doing it, I called him his rock star tour, because he was going around different communities across the country and giving these talks in community centers and what have you. He gave the talk like 200 times or something like that. So he was on tour.
Okay. I do want to call everybody's attention to the chat where I posted the link to the survey, the really long Zoom link there. Please fill that out at your leisure. I didn't get a chance to find a way to make that in survey, but Paul, you've got your hand up. Let's hear your question.
Thanks, Hans. And Sean, thanks so much for taking the time to join us today and provide this really fascinating information. I'm just down the road in Bozeman, and I'm familiar with some of your colleagues. I don't know if you know Peter Kolb, who is the extension forester. From previous interactions, it's my understanding that Dr. Kolb has really downplayed the influence of climate on fire regimes. And I'm just wondering if you have any thoughts on some of our educators within the Extension Service, or other educators at land-grant universities, or or at universities in general who really aren't making this kind of connection in the way and the with the empirical evidence that you're presenting, and what kind of thoughts you have for our colleagues who really aren't emphasizing these correlations that seem to be becoming clearer and clearer, and how we can kind of reach those educators and kind of help them along to understand the connections that are becoming clear.
Yeah, that's a tough one. That's where maybe some social scientists can come in handy and try to help make that link a little bit better. I mean, in my mind, the data speak for themselves, right? I mean, how do you? It's difficult, and there's more and more papers coming out, more and more studies being published all the time that show these relationships. But maybe, I mean, maybe Dr. Kolb is in the camp of like thinking about fire severity, and I've mentioned that climate isn't necessarily affecting fire severity as much as it is area burned. Um, so I don't have a good way to answer your question. I'm sorry.
Maybe to follow up, if I could, Hans.
Absolutely.
Sean, what techniques are you using to kind of share your information with the public? The Aldo Leopold Institute is very well known. You have lots of resources at your disposal for distributing publications, engaging in talks. Can you share with us some of the techniques that you're using to talk to different audiences, and how you're approaching those audience members who tend to be reluctant, even in the face of this overwhelming evidence?
Yeah, so one of the publishing papers is an important one, but that doesn't necessarily reach a lot of audiences, right? It reaches the scientists. So to reach other audiences, what I do is I oftentimes will work with the people at my station, the Rocky Mountain Research Station, to write up what's called a research brief, and they will distribute it to lists. And I always send these research briefs to the Northern Rockies Fire Science Network and other networks, and they disseminate as they will, but that doesn't reach all the audiences, of course. I pretty much do webinars almost anytime I'm asked, which is why I'm here. And that's probably it for this next paper I'm going to publish. I showed some of the results in this talk. I plan on writing up a piece in The Conversation, if you're familiar with that. So it's kind of a summary, more common language summary of the study. So that's what I'm planning on doing. If there's other ways to reach broader audiences, I'd be glad to hear it.
Okay. David has his hand up. He's been waiting patiently. Go ahead, David.
Yeah, thank you very much. This is mostly new information to me. So I live in the East, so I do think about fire in a personal way in relation to the smoke in particular that we've experienced out here. So I'm not sure you're going to be able to answer this question, because I don't, or you'd be, I don't know how far your science goes, because you did frame this as a Western oriented talk, but I wonder about the extent to which you think that at least the general kinds of findings that you have out in Western forests do or don't apply, sort of like, at least by common sense, to Eastern forests. And part of the question I have in relation to that is, I know in our part of the country, in my part of the country at least, there's been I'm thinking about the effect of agriculture on the forested landscape, and the really extensive land clearing that happened, in the late 19th, early 20th centuries, in our hardwood forests, and also because of railroads, the amount of fire that was. So anyway, I just wonder if the history and the species and the nature of the ecosystems are similar enough that you can make comparisons, or would you say, whoa, don't even think about making comparisons?
Right. Well, I wouldn't make direct comparisons, but I do know I I do have some knowledge of the East. I try to downplay it a little bit because I mostly focus on the West, but there's our evidence for fire in the East is lacking a lot. We don't have we don't have a lot of those fire scars that I was showing because of what you mentioned. The record's been erased through land clearing and what have you. So, but there are some, and people are looking hard for them. There are more and more records, these fire scar records from the East. And it showed there being quite a bit of fire. And there's also some fairly strong evidence that kind of the eastern temperate forest overall has actually undergone substantial changes because of the lack of fire. There's actually a term for it called mesidification, if I'm saying that right. Things are getting more mesic, things are getting more wet because a lot of the forest there were more oaky and open and drier hardwood types. And then when fire was removed, you start to get the maple and other more mesic species that are fire sensitive coming in. And so the fires or the lack of fire has actually changed the eastern forests quite a bit. And it's incredible. I almost consider it like a biome shift in a way because the fire was removed from the eastern forest. Some people would argue the changes on the eastern forest are more profound than they are in the West. There's a great paper by Greg Nowacki and Adams, or I forget the other one, but Greg Nowacki about this idea of can't say this word, whatever. Things got more mesic when fire. All the tree species that came in are these wetter maple types. Mesidification. Yeah, that's the word.
I'll wait, but I have lots more questions if nobody else does.
Well, I don't see anything in the chat oh, here we go. We got one. Jennison did post in the chat that something NECI could think about for the future. But specifically, Eileen asks, are officials in Canada working to mitigate fire severity? And this relates to the Canadian wildfire smoke that we all experienced last year.
I know in the southwest Canada, they are working to mitigate fire severity. In eastern Canada, I don't think so, but I don't know entirely. But I'll say the eastern Canadian forests are a lot different in a way that they were not historically. They didn't have frequent low severity fire like that I was mentioning in the western U.S. So because of the tree species themselves and the climate they have, any efforts to mitigate fire severity are probably going to be less effective than they would elsewhere. And that's kind of an unfortunate reality, I guess. There's the paper. Thank you, David K., for putting that in there.
All right. Jennison's got a question.
Thank you. Can you hear me okay?
Yes, you sound great.
Awesome.
Your audio is good.
Okay, good. Thank you, Sean. This was really informative and helpful. So I'm in Florida, and in my extension work, we work with very large landowners who are transforming like tens of thousands of acres of land from either pasture or, unimproved pasture or forest land into new urban communities, new cities, basically. And just yesterday, I was on site with a client who is, it's actually Rayonier, so one of the largest timber land owners in the country, and they have a project that's like 30,000 acres. They're going to be building 30,000 homes. And so related to your talk, one of the key issues we're trying to help advise them on and push them to be more proactive in terms of their climate resilience and, prepping for what's already here today, climate resilient forests and landscapes and common areas. I mean, just as you know, and this is in the East, so it's very different from the West, but I wonder, with the knowledge you have, like what kind of guidance or are there resources out there that we could like point these very large landholders to, or people, that I could go to in the Southeast or in Florida, who you would recommend that could help us guide them on doing this in as sustainable as, I mean, I know sustainability is a moving target. We're never going to get there, but like, just in terms of prepping, keeping that climate change in their minds, like at the forefront of their minds, to prepare for forests that are more resilient to the climate we're in today.
Well,
Thank you.
yeah, well, forests that are resilient to fire are going to be more resilient to climate, because oftentimes fires act as a catalyst of change, as I mentioned. In the southeast, there's actually a lot of prescribed fire that occurs, and you probably know that. And I'd say that the southeast probably does the best. They're probably treat more acres or treat more area, and the communities seem more accepting of it in the southeast than anywhere else in the U.S. So, I mean, I would think to keep fighting that fight, keep the prescribed fires up. And there are a lot of great fire researchers in Florida you could probably tie into. There's like Tall Timbers. And I know there's others too. I'd have to look it up, but they've got really active prescribed fire on the Air Force bases or the military bases in Florida as well. And so those folks would probably be a good resource for you. But I know that people don't like smoke, but try to keep up the prescribed burning in the southeast.
Awesome. Thank you so much.
I don't see anything new in the chat. David, you've got your hand back up. You're seeing a gap where you can ask a few more questions. Go for it. You are muted, David.
Yeah, and just seeing nobody else raising their hand again. So in the context of climate change and the time scales that you were kind of looking backwards to and forwards to, I have kind of two questions. One of them is like, how should we be thinking about the role of forests in carbon sequestration? Like when I hear a lot of my colleagues talking, I'm a social scientist, so I don't know anything about the science. I shouldn't say know nothing. I don't know much about the science of this, but I hear a lot of other people talking about the significance of forests as a carbon sink. But if they're going to burn up anyway, like how should I think about that? That's one question. And then the second question is, when I think about the climate changes in the future, and let's stick to North America here, should we be expecting the same kinds of forests to be growing back after a fire, whether it's a prescribed fire or not? Or should we be thinking about, hey, this is going to be a different kind of ecological regime that they're growing into, and it's going to be a different kind of forest?
Yeah, those are both great questions. Your first one about carbon capacity or carbon sequestration. I personally get very uncomfortable at the idea of trying to use carbons as a carbon dump, I guess, because of this idea of the inevitable fire. These carbon offsets, don't get me started. But there's a great
I
paper
might
out
want to
there
get started, by the way. Might be fun.
When I'm not being recorded, okay?
Okay.
There's a great paper by Matt Hertow about kind of carbon and forests. He's at University of New Mexico. And there's this idea that we can have forests that have stable carbon, where they can, they can keep carbon after fires because a lot of the big trees survive. Versus if you try to maximize carbon, your carbon's going up, you have the inevitable fire that like kills all the trees, your carbon dives, right? Your carbon goes back up, ramps back up in the absence of fire, but then you have the inevitable fire, and all that carbon gets released again, right? And so if you want stable carbon, what a lot of folks in my circle are saying is that stable carbon means less carbon, I guess. Like we can have forests that have less carbon, but they're going to be more stable under climate change and under active fire regimes, or under the inevitable fire that's bound to occur. Your question about basically, it's basically about species range shifts in climate change, right? And yes, I mean, the climate's changing, and the fire regimes are changing, and different species, just stick to trees. Different tree species are, more suited to some fire regimes and climates than others. So we could expect new things to move in, right? The science suggests that the more severe the fire it is, the more likely stuff's going to move in, because it's opening up all that ecological space. But a major concern I have, especially when we're thinking about trees or any organism that doesn't have a very basically dispersal capabilities that are very far, right? Like the emerging climate for wherever you're sitting, David, the tree species might be 200 kilometers away, and if they don't have the dispersal capabilities to move 200 kilometers, then there's almost like a void, I guess, in species. So, and this brings up the idea of assisted migration, of course, which is controversial in some circles, but the climate is changing, and some species are not going to be able to keep up with that climate change. If you're familiar at all with the climate velocity literature, that's fairly interesting, because the climate velocity literature suggests that the climate's moving faster, farther moving north faster than a lot of species can actually naturally disperse.
Okay. Now, David, do you have one last question? Because I don't see anything
Good,
in the
if no one
chat.
else does. All right. No one else? All right. So about 10 years ago, my daughter was working in Texas on a project where she was measuring duff, and I think it was a pine forest. And she kind of introduced me to the idea. I think this relates to what you're talking about, but that's what I want to check on. So she was talking about the difference between fires that sort of stay down at the ground level versus those that get up into the canopies of the trees. And now those are radically different kinds of fires with different kinds of spreading capability. And I don't remember what it was all about, but it impressed upon me that there was a very different in kind of the nature of the fuel source. And I wonder if what I'm remembering relates to the part of the message you were trying to give today.
Right, like the surface fires that you were talking about are what I would call, these lower to moderate severity fires, versus the crown fires would be these high severity or stand replacing fires, because they're replacing the trees that are currently alive or currently there. And it's totally, again, I come back to this idea that fuels are driving fire severity. So the more fuels you have, litter, duff, small trees that are alive, small trees that are dead, the more likely that fire is to move from the forest floor up into the canopy and be a high severity fire, canopy fire, stand replacing fire, whatever you want to call it. But yeah, fuels are a big deal, right? And so yeah, it's cool your daughter was working on that.
Thank you. Yeah, she had a great time doing it.
All right. Well, we're getting close to the top of the hour, and I don't see any other questions in the chat. So we're going to put out last call right now. If anybody has one quick question, I'll wait 7 seconds. And if not, we'll appreciate everybody's time and attention today. All right. Well, thank you, Sean, for presenting today. Very good work, interesting information. Thank you all for participating and asking some great questions. We'll hopefully see you again next month. Have a great day.
Bye, everybody.
Thank
Thanks
you.
for the opportunity to present.